Blue curve is Iran, red is Egypt. In 2006, 2007, Iran became the country number 1 in the Middle East, even over Israel. And in 2008, you can see it is actually the country number 16 worldwide. They managed to do that in 5 years. 5 years of activity. They managed to come from the country number 134 to the country number 16 in the world. 5 years. And they did that through coordination action. Basically what they did is they said, we need a national nano initiative, a plan that says, what are the most important areas that we need to work on? Who are the most important people in Iran that we can work with? And how much funding they need? Let's put a single plan and work from there. Now Saudi Arabia is trying to do the same thing, and we hope that Egypt eventually will do the same thing. So, now a lot of people would ask, well, nanotechnology, when I started my lecture was that. Sounds fancy, sounds expensive. There's a lot of people putting a lot of money in that. Well, why now? Why is it the right time for Egypt to go into this? We've looked at 3 technologies in the past 100 years. The first one is plastics. And in blue, the idea of the lamp means an idea in the lab. The dollar sign means a market size. Plastics started from 1920 to almost 1940, and then it's a market opportunity where you're generating money out of it. Biotechnology is exactly the same, early 50s to early 70s, and then this was in the lab, and then you got a market size. The internet is exactly the same thing. 1973 to 1993, 20 years, incubation period, and then you go to the market. You know, if you remember, I told you, when did nanotechnology start? 1984 to 2005. For the first time, we actually have an opportunity to start in this area. For the first time, we're actually coming into the race early on. We have a potential. We have the capability to actually compete. And this is why nanotechnology is very important for a country like Egypt, for developing countries generally. And if you say, okay, well, how come developing countries? These are statistics looking at the total number of publications worldwide in nanotechnology and how much of it is coming from developing countries. Coming from South Africa, coming from Egypt, coming from Malaysia, coming from Sri Lanka. And as you can see, 2006, 2007, we almost reached 40% of the entire body of knowledge worldwide in the area of nanotechnology coming from developing countries. Countries like us over the entire world. So we can compete. We have the chance. And the developing countries are investing in that area because they understand the importance of that. So, now what is happening in Egypt? There are 2 programs in Egypt starting up right now. One in my university that already started in nanotechnology, and one in the American University in Cairo that will start in September. Now this is our program in our university. We're looking at building capacity. What we want to do is to make sure that we have enough personnel and enough researchers to actually work in this area, to actually be able to contribute to the wealth of Egypt from nanotechnology, to capture this opportunity. The way we've designed the program, we've done it in a very fantastic way. We don't want to get you to study a master's program like any other master's program. We want you to be able to take this knowledge and deploy it immediately in the market. So this is what we've done. You study for 2 years master's design. We have a direct focus on industrial application. What are the industrial areas we are interested in? Construction industry, oil and gas industry, water technology, textiles, agriculture, energy. These are the areas we are very interested in. There are electronics, but electronics is very far out at this moment to contribute in Egypt. And how you're going to learn about this? You study courses, you go into the lab to work on techniques like I've shown you. You're actually going to be using these techniques for 2 years. And by the way, this is the first program in the Middle East and Africa. There's no one else other than us providing this program. And what you're going to do is that you're going to go into the lab, you're going to work on these things, and when you write your master's thesis, which you will start working on from day one, you start to have to work in one of these industries. So you say, I'm producing nanomaterials, fine, but where are you going to use it? You're going to use it in the construction industry. Show me how you're going to use it. It's not just that, oh, it has a potential application in construction. No. You're going to actually go to the factories, you're going to figure out what are their problems, and how your material that you've developed can actually help them. And what are the problems, and what are the impact of this technology on them. So you come out from these 2 years of Masters of Science with actually a working knowledge of the industry you want to work in. With a very advanced understanding. Now these are the list of courses that are going to be taught. Running along that, we have our research program where we're going to be working on printed electronics, and I'm going to explain a little bit what is printed electronics. We're going to be working in membrane technology. We're going to be working in renewable energy. So, our program at Nile University, we have two things. We have the research component, which is purely research, eventually going into direct application in these areas, and we have an education program. The education program I discussed earlier. So in here we're going to be working in printed electronics, and the advantage of printed electronics is basically you have an inkjet printer, but you print material, and when you print these materials you can print your circuit board, you can print a device, and you can use that device actually going out. An example of this technology existing nowadays, if you go to any shop or any, you buy clothes, you got this tag that is stuck inside your clothes. This tag actually beeps if you take the finger out. Most of the time, the tags that are done on the paper, these are done with printed electronics. There is no one in the Middle East fabricating that. We want to do that. And fabricating it, and we have the capabilities to do that. Membrane technology. All of us know that Egypt and the Middle East is in a very big problem. We have, every day, our amount of water is getting less and less and less. Right? Can you imagine that there is not a single company or a factory or a lab in the entire Middle East that can fabricate a membrane to clean water? It doesn't exist in the Middle East. We have to buy these filters from outside. We build everything in the water filtration system except the actual membrane, where the whole innovation is. And this is what we're focusing on. And we're not only working on it for water applications, we also want to use it for gas separation, so for the oil and gas industry, and for the pharmaceutical industry. The last part we're going to be working on is renewable energy, solar energy, and hydrogen production. But I'm going to talk about this later. Our future expansion is in something called photonic crystals, and this is for telecommunication application. And basically, a photonic crystal is a crystal made out of metamaterials that allow you to bend light at 90 degrees without losing any of the coherency of your light. So this has a very important application for internet, for telecommunication, and we want to be able to build these crystals in our labs. This is the webpage of the Nano program, and we have accepted already 17 candidates in the first run of applications. The next run is, the deadline is 26th of August 2010 for application. We are accepting engineers, all different disciplines of engineers, chemists, physicists, mathematics, pharmacists, biologists, people from agriculture. We are accepting all of that, but you have to understand the success rate is very low. We have over 50 applicants, we only accepted 17. Okay? So please check our webpage, see what is the application criteria. We have scholarships, we have RA positions, and our lab, we've managed to raise about $4 million US in funding for this program. So we do have the money to build the equipment and to build the lab. Thank you very much, and I'm open for any questions.